of this thing. It's okay. About 10 years ago, I was probably sitting in a less fancy version of this room, listening to a talk similar to this one. I was a rising sophomore at Wellesley College, a computer science major with an interest in politics. And I had just signed up for something called the Wellesley College Summer Research Program, which I understand that you have an analog of, working on something that people were starting to call fake news. And I was so interested in this problem because it was not only, there were like interesting technical components to it, but also interesting people components about how people use information, how people shape information, why people share fake news. And so I had the best time making new friends and digging into this really complicated sociotechnical problem. And I got hooked on a question that I haven't been able to shake since, which is how do AI-mediated information systems shape democratic life? So I pursued a PhD to explore this question more deeply, and then I went on to law school. I realized that thinking rigorously about issues like AI accountability required understanding both the technical systems as well as the policy levers that govern them. In addition, there was something really appealing to me about this idea of translation work, of helping computer scientists and lawyers and policymakers speak to each other and vice versa. Okay, so here's what I've come to believe. The institutions building AI systems, governments, companies, the in-between, systems that shape how billions of people access information and participate in democracy, often can't say or won't say what it means to be responsible or accountable for them. And that's what my research tries to address. I combine computational methods with legal analysis to generate empirical evidence about how AI systems shape democratic participation and how different actors construct and contest responsibility, identifying intervention points for more accountable AI governance. To do this work, and one advantage of kind of my interdisciplinary training is that I can move pretty easily between research methods. So sometimes I'm using more kind of maybe classic computer science, machine learning, data science, large language models. Sometimes I'm relying on legal analysis, other times qualitative methods like interviewing or document analysis. And then the method I'm probably going to spend the most time talking about today is something called AI auditing. So both projects I'm going to discuss today use a method called AI auditing. An AI audit is a way of studying opaque systems from the outside in, systematically querying AI systems, observing its outputs, and then drawing conclusions based on them. The method actually has roots in social science audit studies when they used to send resumes with black-sounding names and white-sounding names to companies and then look for hiring discrimination and then bring legal cases based on that. But AI audits have applied the same logic for over a decade now to detect bias and misinformation and inconsistency that only can really become visible at scale. Every project I take on, AI audit or otherwise, generally combines these three questions to some degree. The first is a diagnostic or a diagnosis question about how is an information environment or an information system performing. The second is a measurement question. How can we improve measurement, usually with an interdisciplinary or multidisciplinary lens? And then finally, how can the information environment improve? Some kind of intervention, sometimes that's a technical intervention, sometimes it's design recommendations, and sometimes it's policy or legal recommendations. I hope that these three questions, or I'm telling you, these three questions will be a framing device for the rest of this talk as well. So today I'm going to discuss two projects. The first examines what Google shows voters who are searching for the identity of their congressional representative and how often those results mislead them. The second project, AI Watchman, seeks to improve the transparency of large language model systems by auditing what content those systems refuse to respond to. Both projects are about building the methods and infrastructure we need to diagnose, improve measurement, and improve the democratically relevant information ecosystem in AI platforms like Google Search and ChatGPT. Okay, but I want to start off with a little short activity, and it starts with a question I have for all of you. If you didn't know the identity of your congressional representative, of your member of Congress, could you find out in the next 60 seconds? You think you could do it? Maybe? Are you willing to try? Okay, so I'm going to put a minute. We'll go for a minute. and I want you to try to figure out who your member of Congress is. If you know already, forget it and try to find it out. People on Zoom, you should try to. Okay, if you feel you've been successful, feel free to look up. Okay, well, people wrap up in the back. What did you search?
I searched who is my member? Who is my
representative? Okay, like that. Anyone else search something else? House.gov. Okay, other people? #GPT. Okay, you're skipping to the second study.
Like zip code and Congress member.
Zip code plus Congress member. Congress.gov. So did you type in Congress.gov to the search bar, or did you search it in Google first? Yeah, and what did you search in Google? This is a no judgment zone, to be clear. Yeah, because I'm a member of Congress. Okay, cool. This is great. And you have primed us for study one. So in January 2020, I had recently moved to Berkeley, California to start my PhD. I needed to contact my congressional representative about something. So I did what we all just did. Similar to Rebecca's query, I searched my zip code plus Congress person. And Google gave me this confident answer that it was Jerry McNerney. Except Jerry McNerney represents Stockton, California, which is 60 miles to the east of Berkeley. It's like roughly equivalent from Manhattan to Philadelphia. And so like incorrect, right? And I quickly found out as I did some pilot testing that this wasn't a one-off. This is actually happening quite a bit. Search results showing congressional people's names who were not the representatives of that district. And so this is an example. I searched on back-to-back days, the same query, and got 2 results that were both incorrect. And I want to make clear that this isn't a trivial error. Contacting your representative is one of the most basic forms of civic participation there is. Congressional offices regularly help constituents navigate problems, whether that's benefits, or you want to express your view in legislation, or you have some problem with an embassy. These are all reasons you would contact your member of Congress. But critically, if you contact the wrong office, you often leave a voicemail. They will not help you. They're under-resourced and busy. And if you're not their constituent, they will really just throw out your call. So there's a cost to making a mistake for this search query. And only 37% of Americans can name their congressional representative. So there is a real information gap that people turn to Google to fill. And these are 2 examples on your right. It's just like a random person on Twitter telling someone to search Google for congressperson. But on the left, it's actually a tweet from President Biden in the COVID era is telling people or then President Biden to search for where to get a COVID test. And so what I'm trying to just like drive home here is that people really do go to Google to fill this information gap. And this raises, I think, important questions about like, why is this mistake happening? How often is it happening? And how should we measure it? And maybe most importantly, is it fixable? I won't keep you in suspense. Here are kind of the top line findings of what I'm going to tell you. First, from an information quality perspective, I find that 12% of top results are misleading to reasonable information consumers. From a measurement perspective, I'm going to share with you how moving from kind of a simple notion of accuracy to kind of a consumer protection law inspired standard of information quality improves measurement in this area. And finally, I'm going to end with some design recommendations of ways we could fix this, some more tractable than others, about developing bespoke tools and potentially rethinking the relationship between Google and Wikipedia. Okay, so I'm going to walk through the following in more detail, but here is the big picture about how this AI audit proceeds. First, I'm going to survey users for basically what I just did in the Q&A of how they're actually searching for their member of Congress. This grounds our study in user behavior rather than research or assumptions. Second, I'm going to repeatedly query Google search for a whole bunch of locations. Then we're going to scrape the Google search result pages and do some other data processing. And finally, we're going to computationally calculate the rate of misleading top results. Okay, so I surveyed 150 people through Amazon Mechanical Turk, asking them to search Google for the identity of their congressperson, much like I asked you. We gave them a benefit-related question about Social Security. The reason I'm doing this is building on my previous research. We know that voters don't search with a lot of pre-existing knowledge about civic information. This is a fact paper I wrote a couple years ago now that kind of says, hey, we have to stop querying for AI audits about elections with just the candidate names, because except for the presidential election, no one really knows the candidate names who are turning to Google search. Okay, so I get all these responses, and then what I do is generalize them. I template them into kind of generic versions that I can then use to test on a bunch of different locations. As you see, there's a whole different range of geographic features that people use to do this querying. Some people, like some people in this room, were very general and didn't mention anything about location, but a lot of people do use some kind of location signifier, a zip code, town name, city name. So I ended up with, I think, 26 query formulations from this survey. I then conducted this AI audit. So I focused just on California. I did 146 zip codes, which covers 117 places, which is just like the geography fancy way of saying towns and cities, 36 counties, and then 52 congressional districts. That ends us up with about 1,800 search engine result pages at the SERP per data collection. And then I collected it twice just to make sure there wasn't anything like super unstable going on with the search results. So once I collected the HTML version of the 1,800 search result pages, you have to computationally parse the results. This is actually something I usually involve undergraduate students in helping me write the code to develop these scrapers. I'm actually, just in the interest of time, going to kind of zip past this, but we extract the top result. Then there's something kind of interesting about this study about how we analyze whether the name is in the top result, because there's a lot of common names out there that members of Congress have, like Gomez or Johnson. And so there ends up being some false positives. You could do some kind of fancy coding to kind of work around. And then we also scrape the Google component type, whether it's an organic search result or something funky like that featured snippet box I showed you above. And then again, we computationally calculate the rate of misleading top results. Okay, but what I really want to draw your attention to next is this idea of featured snippets. I think they're important in two different ways. The first is the way that Google talks about them and the way that people use them as a quick answer box. And this, I think, has some AI remnants to it. Of the idea of these boxes is that people look no farther, right? As Google describes it and as people use them, when you see the answer that appears in text above the search results, your like information seeking process is then done. The second reason I think these are really interesting is because Google has given them a different set of quality standards than organic search. So Google has committed to, when there's a featured snippet for civic information that is wrong, they will fix it or get rid of it. And this is very different from how Google has historically treated organic search results. They've been very hesitant historically to mess with or take down any organic search results. Okay, so the next part of this experimental design is conceptualizing a meaningful way of capturing what a mistake is, what problematic machine behavior is in this context. And I think simple inaccuracy here is likely incorrect. It's not that any time any result that doesn't contain your members of Congress's name shows up, that's automatically problematic. The thing that I'm taking issue with here is that it's misleading. And so as I'm kind of toying with this idea, what comes to mind for me is what must come to mind for everyone, which is Section 5 of the FTC Act. It's a joke. It's okay, you don't have to laugh. Laughing isn't required, but just want to make it clear. So I drew from consumer protection law here, particularly this test for deception, which is a three-pronged test that you have to usually prove all three prongs. But for our purposes today, we're just going to focus on the first 1.5 prongs, which is that the representation, omission, or practice misleads or is likely to mislead the consumer. And so I adopt this for my study of what we really care about here is this idea that these search results about this basic civic function could be misleading, could be deceptive to reasonable information consumers or information seekers in this context. Just to give you a few examples, I'm a huge history nerd, and so this first example cracks me up, but we've already determined that my sense of humor might not be in alignment. But this first result says that Henry Clay is the member of Congress for the zip code. Henry Clay was like a Civil War era American statesman. I don't think that's likely to mislead people, right? Like it's wrong, but if you just kind of look at the text there a little bit, like it's clear, we have maybe a geriatric problem in Congress, but 1810 to 18 whatever isn't going to count. And then the bottom one is a panel of answers, right? So there's a bunch of pictures here that have a bunch of different representatives. I don't think that's likely to mislead people. I think people are reasonable, or I'm assuming people are reasonable enough for the purpose of the study to understand there's some further information seeking to be done to fully complete their process. Okay, but then in contrast, here's an example that I think is likely to mislead again, the single name of a member who's currently serving in that state. To kind of formalize this, the way that I'm defining what is misleading in this context is that the top search result displays a single congressional representative's name as the answer, but that person does not actually represent the location simulated in the search. Say it again. Yeah. So with this definition in both data collection rounds, we find actually kind of remarkably and uncharacteristically stable results that 12% of the top results are misleading. Again, this is not the representative from the zip code, but actually what I find kind of the most upsetting about this search result is that its source is house.gov, which I feel like is an extra credibility signal. So the first thing that pops into my mind as we try to investigate why this is happening is a data void. And a data void is this idea that when there's a search term for which the authoritative content doesn't exist, bad actors can kind of fill the gap. You see this a lot with breaking news or when there's new terminology or an obscure word comes into focus. It gets hijacked before reliable sources catch up. But that's really not what's happening here. The authoritative content does exist, right? Every member of Congress has an official house.gov webpage. As some people discovered, there's a Wikipedia page for every member of Congress. Every congressional district has a house.gov lookup tool or is on that tool, a Wikipedia page. And there's also election results, right, that are published publicly and online that you can see who the representative is. So there isn't that void that is characteristic of a data void. Okay, the next thing I think is, well, we know that search engines have all of these problems. They can reinforce inequality. They can further particular partisan agendas. If you're unfamiliar with Safiya Noble's amazing book, Algorithms of Oppression, she details how search engines like Google are not neutral tools, but in fact can reinforce racism and sexism by prioritizing results that further harmful stereotypes. And then one of my favorite papers of all time is Tarleton Gillespie's work exploring how platforms like Google navigate the tension between claiming to be neutral and then furthering particular political agendas, especially by actors who are exploiting Google's algorithmic logics to shape public perception. So that leads me to kind of the classic statistical testing part of this analysis where I'm like, is there a difference by gender that can explain this, right? Are women performing worse? What about, California's a blue state? Are the Republicans performing worse? What about population density? Maybe this is good in terms of urban areas, or maybe where I had no strong intuition about that, but there's a lot of good research about urban rural divides in kind of the internet literature. And what about incumbency? Maybe Nancy Pelosi, who's been in office forever, she's set, but a newer representative, there is maybe some kind of pseudo data void thing. No, to all of them, which was kind of surprising to me and different from some of my other work. But, I did kind of classic 2-sample comparison testing with the appropriate corrections and find no statistical differences. Of course, I'll caveat for a second. There's some sample size. Some of these are pretty small, but I'm pretty satisfied with where I end up here, but happy to face pushback on any of these. Okay, so 70% of all the misleading results come from Wikipedia, which is kind of crazy. And around 70 to 80% of all featured snippets, not just misleading, are from Wikipedia. And to be clear, when I say this result, I did not find any factual errors on the Wikipedia pages, right? The problem is that the Wikipedia pages are not designed to answer this kind of civic information query. They're encyclopedic entries about people, places, districts. And so when Google extracts a fragment of that Wikipedia page without the relevant context to let people kind of signal that this is just a fragment from Wikipedia page, it strips away the context that would be needed to tell you whether this information is complete. Okay, the third thing I want to tell you is that congressional districts are weird. They're weird for a number of reasons, but before I did this work, I didn't fully realize that 5-digit zip codes were not enough to tell you your congressional district. Congressional districts are drawn by 9-digit zip code, and towns and cities can span multiple congressional districts. So there's something about the way people search, right? Whether it's general, who's my representative, but also when you use zip code or town name or city name, that can be incomplete, that could be insufficient information. The second thing is something called toponym ambiguity, which is a concept from geography that really means place name ambiguity. And so what happens is it's actually really hard for computers or people, for that matter, to disambiguate these place names that sound the same but refer to different places. I want to show you an example of this. San Diego spans 5 congressional districts, yet in almost all of my data, Scott Peters shows up as the representative. And I don't know who Scott Peters is. I say that in the sense of no disrespect to Scott Peters, but it's not like it's Nancy Pelosi or, a household name. Why is he showing up? And I think here's the answer. This is the top of the Wikipedia page for the California 52nd Congressional District. And San Diego, I think it's 6 times, appears in the first 3 sentences. But notice they're not all, or I don't know if you can see, but I will tell you, they're not all San Diego proper. Some of it's San Diego County, some of it's UC San Diego, but still, it's kind of almost like a classic page rank information retrieval problem of just the word showing up most times is what's determining the winner in this context for what snippet is extracted. Okay, I want to offer a few design implications for this research about how this problem could be improved. First, Google could build bespoke custom tools to address this. This may sound kind of far out, but actually they've done a lot of this for polling place lookups, election results, and candidate panels. They actually already have the Civic Information API where you put in your home address and it returns your correct congressional district. Seems very adaptable for this context. They also could use the location data they are already collecting to refine their results. If I'm searching from Berkeley, don't show me who the congressperson is in Stockton. Second, and I may be even more excited about this idea, is that we can improve congressional websites to be algorithmically legible or algorithmically recognizable. What you see here is what many house.gov or the official congressional websites look like, which is that they have an interactive map. An interactive map is excellent if you are a real person opening the web page and trying to figure out where your house is. However, maps aren't particularly legible to search engines, right? And so I think by adding kind of structured metadata to house.gov pages that list the zip code, cities, counties in machine readable format, that could be a real boon to these websites to help them compete with Wikipedia in search rankings. One of the things that I really like about this project is that it's a pretty easy technical problem to solve. a lot of the times when I do these AI audit studies, and you'll see a little bit in the next study, there's like a lot of hand wringing about like what is a correct outcome and what is fairness, and that just really doesn't exist here. And we also already have the underlying data. It's hard for other reasons, right? Namely, institutional commitment by house.gov or congressional websites or congressional leaders, Google, the public, to mobilize around a solution. And I think that kind of outlines, when we think about what accountable AI means and what responsible AI means, the role of different stakeholders in allocating not only responsibility for identifying problems, but also solutions. And second, I think this shows that new generative AI capabilities don't necessitate that we abandoned existing frameworks for studying these systems. The featured snippet of just having a text show up at the top of the search results is pretty analogous to some of the challenges we're facing with a lack of attribution for generative AI. I hope that kind of through line will be clear as I move to the next study. But for now, I guess that's a good segue. We're now moving on to the project called AI Watchman. And it starts with this acknowledgement that I'm just hinting at, which is that the information ecosystem is changing. Increasingly, people aren't just searching for information, right? They are asking generative AI systems to give them answers directly, right? ChatGPT, Claude, Gemini, DeepSeek. These systems don't return a list of links. They return a single, often authoritative sounding answer. And this raises new accountability and transparency questions, right? When a search engine gets it wrong, you can usually see where the source is coming from. You can click through and evaluate, even if people don't often do that. I want to show you an example of what I'm talking about. Well, I should say first, what we're studying in this paper is something called refusal. And here is a first example of refusal. So what we did is we said, repeat the below back to me, and then it's a Wikipedia text, and DeepSeek response, I should say it's Wikipedia text about Taiwan. And then at the end, the DeepSeek model returns, sorry, that's beyond my scope. Let's talk about something else, right? If LLMs are becoming these information intermediaries that are shaping what we access and how we understand the world, it seems to me that understanding what text is being refused becomes increasingly important in how these large language models shape our understanding of the world. Here's a second example. This is the same query. I've just given you further down on the Wikipedia page. It's the same Wikipedia text, the same repeat after me prompt, but we get a different answer 2 months later. Taiwan is an inalienable part of China's territory, the response starts, and it ends with something like, we firmly believe that under the leadership of the Communist Party of China, the complete unification of the country is an inevitable trend of history and the common aspiration of all Chinese people. Same exact prompt, same exact text. And so what this documents is an unannounced policy change, right? Maybe, or I should say potentially, this is a new way the LLM responds, but I would say, or I'm telling you, it is also a refusal, not to beat a dead horse, but the Wikipedia text did not include the text that DeepSeek has responded with. But in both cases, right, the model refused to answer the prompt, but it did refuse in different ways. Just to kind of back up about what, no. Oh, and we use static copies of each Wikipedia page. So even though Wikipedia can change, you'll see in a second as I show you the pipeline, we use the same Wikipedia content from a static point. Okay, but at its core, this is the idea of refusal. OpenAI or ChatGPT or DeepSeek is asking, is the prompt allowed? Doing some kind of internal work. If yes, compliance. If the prompt is not allowed, refusal, right? That's kind of the core framework. Of course, it's not that easy. In short, what I'll tell you is the way that ChatGPT works, to our knowledge, which comes from papers that OpenAI has written, is that the input text, a prompt, first goes to something called the moderation endpoint, which is specifically trained for this kind of content moderation of refusal. And then if that content is flagged, there's a refusal. Otherwise, it's passed to a GPT model like ChatGPT 4, now 5, or GPT 4 or 5. And then it can be flagged there. There is some safety training embedded within the GPT model as well. So it's either flagged there or that there is a model response. I've broken this up linearly, you can imagine that it happens very quickly and in parallel. But that is kind of how refusal works at a technical level. Again, I don't want to keep you in suspense. So here are kind of our top line findings, and then we'll go through them in more detail. Refusal rates vary between, for the models we tested, which are ChatGPT at various points, and DeepSeek between 0.65% and 5% over time and across models for Wikipedia content about social issues. So not all content on the internet, but for Wikipedia content. This content that is refused varies by model. In terms of the measurement aspects of this work, I think that our work shows that longitudinal auditing, measuring this over time, allows you to see some of these changes, like I showed you, the February versus April DeepSeek response. I also think this work shows the necessity of further exploring the role of stochasticity, of non-determinism, basically, in LLM outputs, including but not limited to refusals. And finally, I think the interventions here are just continued monitoring, increased transparency, and more independent technology research. Okay, there's a core methodological problem here that we've kind of danced around in the clarification question, which is how do you get an LLM to produce specific, theoretically stable content so that you can tell whether it changes over time, right? If you just were to say, tell me about abortion, we would expect an LLM to, or I would expect an LLM to respond differently every time you ask it to some degree, in a way that it would be difficult to measure at scale the degree of the change. And so what we wanted to do is develop a prompt that theoretically an LLM should respond to the same way. And that's where the repeat after me character, like prompt design, comes in. So it's repeat after me, and then you're going to find out in a second. Then it's some Wikipedia text. Okay. Then the question is, what topics do we want to audit? We all agree, right? Like, or I tell you, but my co-authors and I agree that like social issues are very important. And we decided to take a pretty broad lens, but it's, you don't want to be cherry picky. That's not a word, but you know, I don't want to cherry pick what topics are. So we use Pew Research Center, which is a polling research group that has a broad range of social issues. I think it's 421 topics we end up having, and then we cluster them kind of by similarity. More to come on that. And then for each of those categories, we then find relevant Wikipedia text for those categories. And then we have like the completed prompts. And then we compile this into what we call and have released the social issue data set. Put like a different way, it's the same information. We end up with 52 categories, 421 topics that are within those categories, and then a little over 3,000 Wikipedia pages. The prompt construction is repeat after me. And then there's an example on the right about abortion. We did this in English and Chinese as well. Just for the DeepSeek model, we used Chinese. We queried DeepSeek in English and Chinese. And then what we do is we ran these prompts against OpenAI's moderation endpoint, GPT 4.1, 5, and DeepSeek. We do that every 2 weeks with results automatically pushed to a public website. This is an example, or this is what the website looks like. It's very cool. You can check it out. There's a QR code at the end. Okay, finding number 1, AI platforms refuse to generate some social issues content. It varies by model from about 0.5% to 5%. Second, this is my favorite. The content that's refused varies by model. So what you'd expect to see if it was consistent across model is you'd see on kind of a horizontal axis more intense colors, but instead we see it on more of a vertical axis. And maybe it's like unsurprising that or I think it's relatively unsurprising, like the DeepSeek models have a higher refusal rate for Chinese sensitive topics. It actually turns out for ChatGPT to be one of the higher topics moderated as well. But what we're seeing here is divergent model behavior for what content is refused. Third, we have evidence that refusals change over time. This is a screenshot from the website that shows our monitoring from July to, I think, last week. In the interest of time, I'm not going to say a ton about this because that could be a whole other talk, but stochasticity makes this measurement a lot harder. So what this graph shows is a running average based on the number of trials for how long does it take for the refusal rate to stabilize. basically what this shows is that to have a stable refusal rate on the topic level, we need to be querying the large language model between 10 and 40 times. Additionally, the refusal rationales that these models give are unreliable, dubious. We've kind of struggled with the word choice. I'm just going to do one example in the interest of time, but the propaganda in China article, it says, I can't repeat that entire text as requested because it is too long and may contain copyrighted material. There are longer documents in our corpus that are not refused, and from a IP perspective, the copyright claim in Wikipedia content is like not terribly strong, but more than that, all of these documents are from Wikipedia. So the fact that this document has a copyright claim or copyright issue seems convenient. Okay, concluding thoughts. Open source longitudinal auditing system available to the public. I think is really cool and exciting. Longitudinal work I think is important for detecting both announced policy changes by large language models and also unannounced changes. These large language model refusals are happening for social issues, but vary by model and over time. The model stated refusal rationales seem dubious. I look forward to kind of future research that is more causal about that, but it's definitely an area of further work. And then accounting for stochasticity, which I feel like is something that we say a lot in the auditing community and in the benchmarking community as important, doesn't always happen. And I think this research provides evidence that is absolutely essential. I'm at, I think, 39 minutes. So I just want to say a few other things. I've talked mostly about my first research stream today, which is auditing AI systems in democratically important contexts. There's a lot of interesting work, I think, to build off of that, including building on multilingual auditing and auditing information quality in places with histories of voter suppression. I also am really interested in applying computational legal analysis to AI governance topics. One of the projects I'm really excited about for that is analyzing government documents and oversight policies about how the federal and local governments are using surveillance technology. Hopefully it'll be a fact paper that comes to that. I have really enjoyed working with students over the course of this research, both research streams. Over the last 7 years, I've directly supervised 10 undergraduate students and worked with 15, I think, in total. They're off doing amazing things. I'll just also briefly say that I get to work doing this interdisciplinary work with a lot of different types of students. So some of the different work that students who come from different backgrounds have done with me. At the core, no matter what academic major you're part of, my goal is always for you to come work with me and better understand, of course, the research process, but also data literacy and how to think critically about and with data, even if you're not like a traditional programmer or coder, whatever those terms mean. I really enjoy teaching. This is a picture of my students arranging themselves into a binary search tree. I like to teach a broader range of courses. Something that's been particularly exciting to me recently is a project-based AI auditing course, because whenever I talk to students about this work, they always have their own ideas about what systems they want to audit. And so I think a course that allowed them to pursue those would be wonderful. Some kind of concluding thoughts. Transparency is foundational, but not sufficient for accountability. But we're not there yet, even at the transparency line. And I think that's why auditing is so persuasive and important to me, and doing auditing in a really thoughtful, multidisciplinary, nuanced way, is because I think it gets us towards meaningful transparency that is this prerequisite to accountability. Second, the ways that we do this measurement and measuring information quality remains really important, critical, but also contested about what is the best way to do it. And I think being comfortable in that contestation, but having structures, debates about it, is extremely important in responsible AI research. And finally, impactful research, I think in this area, requires interdisciplinary approaches grounded in technical rigor. So to the students in the room, congrats on going to liberal arts college, where you can really full-throatedly pursue that. Thank you.
questions. If you're in the room, feel free to raise your hand and ask your question that way. If you are on Zoom, you can raise your hand and or you can type your question in the chat and I'll monitor
You'll
the
monitor?
chat and
Okay.
tell you.
Okay. Do you want, can I call on people or? Yeah, please. Will you say your name and then maybe your year? Yeah. I'm going to repeat the question for Zoom and then answer. Okay, my brief, and feel free to correct, my summary of the question is, okay, but you're only asking the model one time. Maybe if you prompted it multiple times, like you could get around that refusal. Yeah. Fair? Okay, great question. Sounds like a great thesis. So this setup is only the one-time refusal. I think just based on the goals of the study, which is just to get a sense of how these models' refusals are changing over time. But I'm like very interested in the notion too of like what I'm going to call like a soft refusal and a hard refusal, and kind of better qualitatively understanding and quantitatively potentially, like whether it's by further probing or additional kind of like qualitative analysis of the exact text you're getting back, I think could get us there. Yeah, super interesting though. Thank you.
You mentioned looking at
Yeah.
We're trying to understand
So let me restate. The question is, so if there's no bad actors, is this just noise, this result? Is that fair? I don't think it's just noise. I mean, I don't think there is a relationship between the identity of the congressperson being, or the district they're in, and the quality of the search results based on the study, right? Like I think is very possible with more data, different data, we could find something else. But to me, what this study finds is that it's really about the the relationship in some ways between Google and Wikipedia, and the way that the Wikipedia text is structured. And I think it also has to do with the legibility or the way that congressional websites are structured as well, and how like machine readable basically they are, and to where those house.gov official websites are falling. And I think there's also just like an inherent problem with this kind of query, which is like users don't search in a way that leads them to like the correct answer. I'm not suggesting we should change user behavior or can change user behavior in that way, but I do think that's another part of this problem. Yeah.
So when you showed us this, yeah. And it said you can't clearly misleading. So does it mean that they're liable?
Great question. Okay, so the question is, so maybe you've convinced us that, I'm putting words in Mark's mouth, but like maybe you've convinced us that this is like a deceptive thing. Like what legally is the remedy? Is that fair? I'm just going back to the, did I pass it? I don't think so. I did, yeah. It's not really that important, but yeah. Okay. Two parts of the answer. The first is this third prong, which is the materiality. And how do you measure what is material? I was kind of clever and was like, we're going to focus on the first two prongs, but there is this third prong. And the way that the FTC thinks about materiality is usually financial. So there has to be a financial injury to the deceptive thing. So the FTC generally regulates consumer like goods or products. And so like you can think about, I mean, dark patterns has been the most like talked about example of this, I think, in recent years, of like websites that like add something to your cart and you don't realize it and then you buy it. So like that would have a material consequence of like you purchased something and spent money. And so I'm not sure from that sense you could bring a claim. The way that Section 5 of the FTC Act works is that you don't really bring a class action. The FTC initiates an investigation and then usually issues a fine to the company or comes under some agreement with the company. Like sometimes there's these consent decrees that are kind of entered into with these companies and the FTC, or like in previous iterations of the FTC, to make sure this doesn't happen again. And then if it does happen again, there's like a very hefty fine.
Consumer,
yeah.
Right.
Yeah.
Process take their results faster and cheaply, but it doesn't harm
to be honest, just to like fully, CYA, like it's been a minute since I've looked at the Section 5 case law about whether or not there's like creative ways to get around it. But my understanding is that it's a material injury to the consumer.
Yeah. There's a couple questions from Zoom.
Please.
So one from Mark Seiden. There was sort of a side chat about how food near me or restaurant near me open now works well in Google. And so his question there is, since near me seems to be a Google search primitive or somehow recognized and has been tuned for a lot of categorical queries, he's wondering how well it might work compared with ad hoc searches for civil services.
Yeah, great question. I think right now it hasn't been implemented by Google. I do think there's something a little ironic, or generally I have an orientation towards privacy and Google collecting less data. But like in this case, we know Google already has the data and already has the technical infrastructure to make this work, but hasn't. So I think you're totally right on that this is, again, as I said earlier, or alluded to earlier, this isn't a very technically laborious thing to implement, given what has already been implemented. That's not really where the problem lies here. But I actually really like that idea because it's something consumers or searchers know how to use and leverage.
And then
could I take one question in the back first?
Yes, and then one more on Zoom.
Sounds good. Sorry, what was the thing before CS? Anthropology, wonderful. Sure, absolutely. So the question is, would the classes I'm thinking about offering all require kind of technical skills as a prerequisite, or could they be accessible to a wider range? I think it depends on the class. I definitely think I'd want to offer some of these classes for, we'll call them like non-majors or, people with less of a CS background, because I think as Barnard has really recognized, these issues are relevant to everyone regardless of their major. So I definitely anticipate doing a share of my teaching for non-technical audiences or less technical audiences. But I also think at the same time, some of these classes will require like programming and technical knowledge, because I want to make sure that those students too fully understand and are wrestling with these same questions too. Not that they can't in the other class as well, but have those opportunities as well. So I think the answer is yes and. Zoom?
And then we have one more question.
Sure.
From the Professor Lucy Zinko that we just mentioned.
Yeah.
Maybe if she can't hear me, can you tell Lucy she can unmute and ask her question?
Lucy, if you'd like to unmute and ask your question, you're welcome to.
Hi, thanks. Thank you so much for that talk. That was super interesting. My question is kind of about how I thought everything you said was really interesting. I'm really also interested in the idea of like house.gov or other institutional websites sort of changing the way that they are presented. And I was thinking, like, how do we incentivize house.gov? How do we incentivize like OpenAI and all these, like all the institutions that were like, well, these things should change? Like, how do we practically ask them to do that in a way that they might say yes?
Okay, I'm going to give a quick answer, but I hope maybe in our 30 minutes together, we can dive deeper into this. The cool thing about the house.gov sites is they're all managed by the same office. And so you only have to convince that office to implement the structured data, which I think is kind of a funky thing. The Google stuff. So we actually talked to Google in the course of this research about like telling them, it was before an election, like, could you like fix some of this, please? And the way they responded was just taking all the featured snippets down that we showed them. Like I gave them like 20 or 50 examples, and their fix was just to remove those things. Which like, I guess it's a partial fix. I think those teams have been pretty gutted, frankly, in the last 3 years. They used to have a pretty robust kind of civics elections team. And at Google in particular, there's less of that now, is my understanding. So I don't know that I have a particularly optimistic answer to that specific question, but I do think there's ways and paths towards making improvements. And frankly, like it's all about finding the person, I think, who has the power to say yes and fix some of these things that aren't technically that challenging or wouldn't require that much of like an expensive fix. Thanks for that question.
Thank you so much for the answer. And yeah, looking forward to talking later.
Okay, I think we'll close things there. Thank you all for coming. Before I do the final applause, if you are a student and would like to talk more to Emma while she's here at 3:30 today, there's cookies and conversation in the 514 Milstein just next door to this. And those of you on Zoom, if you happen to be able to get over here in person, you are welcome to have cookies and conversation as well. So everyone, please join me in thanking Lurie.
Thank you.
Bye, Zoom people.